Unless until you have any query, do not write anything else in the chat. I don't know why I need to repeat these words each and every day in each and every class. You do not have any query, don't post anything in the chat. I do not need this kind of attendance. We get the attendance from the Zoom report and we take that only. Well, let me start. So today in the last class, I had discussed about the stack and the implementation of the stack. Today we will discuss about another ADT, another linear data structure that is called queue. Let me tell a very simple word that if you say that is this a queue or what is the difference between stack and queue, please understand the difference is in their way you are dealing with a list. Difference is in the way you are going to deal with this. It's not that you will get, it's not like that it's a something special thing like the stack where you, the programmer, has to ensure that push and pop supposed to be done from one end only. In case of queue, the thing is little bit different. In case of queue, obviously the queue you may thought of a simple people are line in front of a ticket booking counter where you may thought of the concept of the queue as this way. The person who is in front of the queue will get the ticket and will leave the queue. And the new person who is coming will be added here. So queue is such a list where the deletion will be performed from one end and addition will be performed from the another end. This is queue. It's a linear element, linear arrangement of your datas. You can access the data linearly. It's a linear data structure. That is why. Again, it's an ADT also. As why ADT? As you are specifying that how data is to be inserted, how data is to be deleted, how insertion will take place, how deletion will take place. You as a programmer, you are specifying that. And queue is a data structure where in normal simple queue, addition will take place from one end and deletion will take from another side. Okay. Now, what is the name of these two end? What is the name of these two end? The area from where the deletion occurs. Now, from where the deletion will occur? Now, who will get the ticket for the first time? That person will be deleted first. So, the person who is in front of the queue, that person will be deleted from the list first, right? So, front end, the end from where the deletion occurs is called front. And the end from where addition occurs, that calls the rear. Okay. So queue is a linear data structure, or the simple queue is a linear data structure where addition and deletions, insertions and deletions are being done from two different ends. The end from where the addition of the elements, insertion occurs, that is called rear end. and the end from where the deletion occurs, that is called the front end. Now, this is the definition of your simple queue. Why I'm telling it as a simple queue, you will understand gradually, because there are few variations of the queue and you will get different restrictions over these to end. Okay. So in some of the book, you will get that insertion is written as in queue, remove is written as day queue. But let me tell you one thing, you should not, means DQ is a special kind of queue. Okay. So if you are being asked that what is DQ, do not tell that, okay, DQ means the delete operation of the queue. No. For the queue, the term is insertion and deletion only. Insertions are being taken place at rear end and deletion is being taken from the front end only. Now, how we can implement it? See, what I have told in last few minutes, that in case of insertion, it will take place at rear end. Fine. In case of deletion, it will take from front end. That means any moment when you are inserting one element, rear must be incremented. And any moment when you will do deletion, front must be changed. Now, in case of stack implementation, what we have done, now we have considered that in top for increment and decrement. For any kind of insertion, top is supposed to be implemented, and for any implementation, we consider that it will be initialized with the -1. So -1 will be there. Similarly, in case of queue implementation, you will do that before you insert any element, the initial value of rear and front will be -1. Now, if it is -1, the moment you will insert the first element. Now, how I can understand that the queue is uh, empty and you are supposed to insert the first element? So, for insertion, you may check if obviously if rear and front both are in -1 status, or you may check the only the front or rear, that if front is equals to -1, you may initialize front equals to 0, and obviously rear also supposed to be initialized as 0. Now, but for each and every step of the rear end, means for insertion, at each and every step, you have to increment the rear. So this rear equals to rear plus 1, like in the last class, what we have done, that top equals to top plus 1. In the similar way, rear equals to rear plus 1. This operation you have to do before you assign the element. Fine. So this is the basic step when you are going to insert in an element to one simple queue, simple linear queue. Similarly, if so, you can look at this with a array version where front and rear is initialized with -1. The moment you will insert the first element, both will be initialized with the 0. Now you may ask that, ma'am, you are inserting the element from the rear end and it's clear that why I'm incrementing the rear. But why front? See, queue is empty, nothing is there, even no, nothing was inserted earlier also. The very initial stage indicated by the -1. But when you have inserted at least one element, there is a chance that you can delete that element. Now, whenever you need to delete the element, you need to use the front. and that's why you need to reinitialize the front as 0 the moment you will insert the first element. So when you insert the first element, both the variable has to be initialized with 0. Now, every time now onwards, when you will insert the elements, the rear must be incremented. So every time you increment the rear, every time you insert a new element. Fine. Now, see, if we are going through the array implementation of the queue, then you will get this kind of scenario when rear will be at the last position, that is rear will already has reached the max minus 1 position. Srija, Shantanu, Nobarun, Deep, Jogesh, Shaurodeep, Rahul Dotto, Deepayan Maiti. Do you think that giving attendance here is a mandatory job? You don't have the at least that much of attentiveness that I'm repeating that you no need to give the attendance. But you are giving as if it's a job. As if it's a job. Next year, what you will do, you will go to the office. Either there will be the card punch, or will be the thumb impression or the face recognition. Go in front of the machine and then leave the office. You will do this kind of thing. Because in your life, the giving attendance is the only job. Fine. So whenever we are going for the array implementation of the queue, inserting a new element, the rear is being incremented. So when the queue is full, then rear will be at the max. Fine. Means you have entered all the required number of elements. As we are, yes, there is a question that why I am taking the -1. In the normal array implementation, we assume that our array indexing are starting at 0 and it will reach up to max -1. This is a normal convention. Now, as we are thinking that it will occur in this way, so that's why what you need to do, that's why I need to initialize the front and rear as -1 to indicate that since the beginning, no element insertion or deletions are being taken place in the queue. Or you may say the queue is completely empty. To indicate the initial status, we keep or we initialize the front and rear with -1. As soon as you insert the first element, rear and front both will be initialized with the 0. Fine. And then for every insertion, rear will be incremented, but front will be at the 0th location. The reason is that front will be incremented if and only if some deletion occurs. So once you start filling out this queue, after some time, the rear will reach to the max -1 value. So max -1. That means if rear is here, that means you have inserted all the elements for all the locations for the queue. But if you are getting the rear at the last end, but you do not know what is the position of the front, you cannot tell whether the queue is full or not. That means what? See here, the front is pointing to the first element, that is front is 0, and rear is pointing to the last element, that is max minus 1. So if front is at 0 and rear is at max, then only you can say that the queue is full. Otherwise, if some of the elements are being deleted, then see, if the 21 is being deleted, then front will be pointing to the 33. That means the front position is vacant, but rear has reached this particular location. So that's why you cannot insert any new element. If front is at 0 and rear is at the max minus 1, that means your queue is really full. If rear is at max minus 1, but front is it anywhere other than the 0, then it means it makes a illusion that the queue is full, but actually there are vacant spaces in the queue. Now, so that is the thing. Now, if I start deleting the elements, then I will increment the front. Fine. Now, up to which level I can continue? Up to which level I will continue? Now, obviously, up to the portion where the rear is pointing, I can delete that particular element for the last. After that, if I increase the front, it will go beyond the rear level. That means if that kind of situation occurs, that means there is no space. There is no element is there and no position or something is there that is supposed to be deleted. So that means it's empty. Achha. Can anybody tell me, means those who are studying each and every day, that's okay. But otherwise, can anybody tell me that when, means it's a very common thing, you may be asked that what may be the overflow condition for a queue? Now, obviously, overflow condition is when rear has reached its maximum position. But when you can understand that your queue is containing a single element, when you may understand that your queue is having the single element. Yes, when the front and rear both are pointing to the same position, that means that queue is having the single element. So, fine, I got the answer. So, for the deletion, obviously, if element exists, then only you will delete. So, if element doesn't exist in the queue, that means either it was never got any element for insertion, so that is front equals to -1, or front has crossed the limit of the rear, that is front become greater than rear. Then also the queue is empty, means whatever the element was there, everything got deleted. So those are, if in that case, if you want to delete any element, that situation is your underflow. Again, I'm repeating that this overflow and underflow condition that I'm discussing now, these are related to the array implementation of the simple queue. If your queue is something special type of, then this condition also has to change. Okay. So for every time you want to delete, check the underflow condition, then print the element and increment the front. Again, I'm telling the same thing that actually we are not deleting anything. We are just moving the counter and assuming that I am not taking the element. In reality, from the array, I'm not performing any specific deletion operation. What I am doing, I'm just moving the front pointer. So it's a virtual thing. It's a virtual thing that, or you may say it's a logical thing that logically that elements are being deleted. Physically, that element may be present. If you consider it as a simple normal array, so that means all the elements are there, even if you have moved the front from to up to some extent. Now, so if I want to know how many elements are present, or if I want to print all the elements which are available in the queue, so obviously your array is from 0 to max minus 1, the array indexes. But whenever you want to print the content of the queue, so logically what it is? Logically, it is that the element which is, means if I want to perform the deletion now, or the element which was deleted last, just after that element will be pointed by the front, and the rear is pointing to the element which was inserted last. So the elements pointed by the front and rear, all the elements in this range is actually the content of your queue. You are not supposed to bother about the entire content of the array. You are supposed to bother that the elements which are being pointed by the front up to the rear. So the elements which are pointed by this, you are supposed to print those as a content of the queue. Okay. Now, so this is the thing. If I want to implement this using the array. If I want to implement the simple queue using the linked list, again, I may take the help of single linked list. Now, just like the stack implementation, where every time you insert a new node, initially the first node is declared as the top, and every time you insert a new node, it becomes the top. So here, for linked list representation of simple queue, what we will do? Now, for the first node, it will be declared as front, and as well as rear. It will be declared as front and as well as rear. And every time, yes, Ramona, if you have any query, you may write in the chat. Ramona, you may write your query in the chat. You have raised the hand, so if you have any query, you may write in the chat. Anyway, so when you are trying to implement the queue, what you will do, you will make the first node as front and as well as rear. Now, from the next step, what we will do, every time you will get a new node, first you need to make a link. For the new node, the link should be made to the previous node, that is the rear. You may say that I can take the front, but that is okay for the first time only. For other time, it may not be okay. So rear is pointing to the element which was inserted at the last iteration. So whenever you are in giving any new element, that's supposed to be added at the rear end. So the moment you are getting a new node, the data will be assigned, the link will be made to the previous node, that is the rear. And then you should make this node as rear. But as a front, unless until you are start deleting, front will point to the first node. Okay. So In case of stack implementation, what we have done, we have created the first node, make it as a top, and whenever a new node is coming, the link part must be assigned with the address of the previous top, and then you declare the new node as a top. Similarly, in the queue implementation, the first node will be declared as front as well as the rear. Whenever you insert a new node, the new node link should be made to the rear, and after that, that particular node should be declared as rear, so that whenever you create any node, it will be added here, and then that newly created node will be reassigned with the rear name. So if I want to implement using the linked list, I need to, as I'm using the single linked list, so this will be info, and the link part, the front, rear must be initialized with the null. Now, what are the conditions to be checked? See, again, I'm telling the same thing like yesterday, that in case of linked list implementation, the overflow condition may not occur directly, as there is no limitation in the linked list number, node number and all. So there is no such overflow. If overflow occurs, that would be the memory overflow. And when you will get that it has occurred, now if your this malloc function is unable to allocate the space for a node, it returns null, then you will may feel that okay, there is no space if the malloc function is unable to allocate the space. But normally that not happen. So implementing using linked list generally does not incur the overflow condition. So whenever you are making the node, you may assign it as a rear. Then the link part of that node must be assigned as null. Info part might be assigned as the data, and the rear is also can be named as the front. So the address of the rear node is also initialized as the front. So for the first time, the node that you have created, that is named as rear and as well as named as the front. Now, so rear, when the rear will be null? Now, you have initialized both of them as null. So rear null means that okay, that is for the first node. If rear is not null, means if at least one node is being created, then you will create the new node, then you will create the new node, and then what you will do, then the rear pointer means the link part will be linked with the new node. Okay, the new node will be connected with the previous rear. The data will be assigned, and after that, this link part will be initialized with the null. Fine. Every time you are go forward, every time this will happen. Every time you will go forward, every time this will happen. And at the end, the temp will be initialized, means step will be given to the value of the rear, so that every time it will go in loop, and every time these operations are being taken place in a proper way, so that every time you insert a new node, first it will be linked with the previous rear node, and after that, that must be declared as the rear. So this is the way you can perform the insertion. Next, if you want to delete, what we expect for the deletion, that if I want to delete a node, if without making one arrangement, if without making any arrangement, if I directly delete the first node, that is the front node, what will happen? Now you may lose the entire track of the list. It happens if you had done all this coding by yourself, you may have faced that this kind of situations may occur, that just moment you call the free function for a first node without realizing that it will lose the entire track of the list. So before you do all these things, you need to keep a copy of the front in a front one variable. Obviously, front one is also a similar type struct node kind of variable to be declared in the program, and that will be declared. Now, if front one equals to null, obviously nothing exists. Front one is having the copy of the front. So if it is already null, that means that there are no spaces. There are no spaces as assigned as a queue. So no queue exists. So if that is, that means the queue is empty. No queue exists. Otherwise, what you will do? Otherwise, you check if front one link is not equals to null, then front one equals to front one ptr, means the node that you want to delete, that is the front, originally that is the front which is assigned in the front one. So what we will do now, it will link, means it will be assigned, or the newly front will be the next node. Initially whatever is there, that front one will be assigned with the address of the next node. Once that is assigned, you can print the value, you can print this value before this line also, that doesn't matter. And after that you can call the free function to release the front. So what I am doing now, front is the original name of the node, that is the first node that you are supposed to delete. First you are taking its address to the front one variable, and if it is not the last node, then you are going to the next node. Means if you consider this I as a node and F in separate node, then I supposed to be deleted. So first you are moving the pointer to the F, then printing the value of the this node, that is I, and then you are calling the free function for the front. Now, and at the end, the new next node, the next node of the previous front will be the new front. So front will be reassigned with the front one. And if it is last node, that means the link part will be null. So you just print the value and you can call the free function directly. So see, in case of stack, we do not have so many cases and all those things. But here, whenever you are dealing with the queue implementation, you need to keep in mind all this. And once everything got deleted, you may reassign the front and rear as null so that it can start its operation from the beginning. Now, till now, whatever I have discussed, if you have any query, please put it in the chat, and otherwise I will move forward. So before that, giving you the option that if you have any query, please write it in the chat. I will try to resolve that. Okay. So I got one request that I need to repeat the deletion. Just a minute. Well, so what we are supposed to, what we are discussing here, that this way your list is there, right? So what we are trying to do now, we are trying to delete. So initially, this is your front and this is your rear end. So what I am doing, or what our code is doing, the front one is initialized with the front one address. Okay, fine. What is the next step? If front one equals to null. So as of now, say all these nodes are here and they are having some values. That means they are not null. So underflow condition is not okay. Now, if it is not a last node, if it is not a last node, so here this particular node, you can see this is not the last node. So if it is not the last node, means if front PTR not equals to null, how it's checking the front PTR? PTR means this part, this link part is null. No, there is a node. So what I need to do? Front one equals to front one PTR. Front one equals to front one PTR. So front one PTR means what? If I consider the address of this node was 1024, this is 5063, this is 1128, then front one PTR means this contains what, which address? Now it's content 5063. So front one is being assigned with the address of front one PTR. So that is 5063, means this node address. Fine. Then you would print the value. Okay. Then free front. Okay. Which one till now is front? Now this particular node is till now front. What is the value of front one now? Front one is now this one. So the moment you will call the free front, the previous node will be deleted, means the deallocation, and then you are, this one is already assigned as front before the free function. So this one now will be called as front. So I think I made your point clear that how things are getting deleted. Now, if it is the last node, you no need to do, You just need to print the value and call the function. Is it clear? Someone has asked me that after free front, how we assign front equals to front 1. I am not deleting the front later. Front is already there. The node which is pointed by the front initially, means at the till now, that node deallocation will occur. That doesn't mean that the variable will go on. Deallocation of this means this is the space pointed by the front variable that is deallocated. That doesn't mean that front get deallocated or front variable get there. Just what happened, the front is now pointing to some null or nowhere. That's why I can reassign the newly, means the next node which is initialized or which is named as a front 1 as front. Is it clear? Is it clear? Okay, fine. So as no other query I am getting, so I am moving forward. See, till now, whatever I have discussed, that is nothing but your simple queue. Now, in simple queue, simple linear queue, if I want to implement it using the array, what we have found? Now we have found that particular situation that when there is one array, your rear is here at the max -1 position. Say 0, 1, 2, 3, 4, 5, 6, 8. And say that some of the elements are already got deleted. So front is at this position. So this much space is actually occupied. But whenever you will want to check that whether the queue is full or not, what you need to check? You need to check whether rear equals to max -1 or not. Right? Because every time whenever you are inserting any element, you need to do the rear plus plus. If rear has reached already the max -1, you will not get the opportunity to increment the rear position. And that's why you cannot insert the element. But at the same time, this much of space is free, 0, 1, 2. There are spaces for 3 elements. You can insert 3 elements, but because of this logic of the simple queue, you are not able to insert the element. So that is the problem of linear queue. Means it may happen that all elements are deleted. Say front and rear both are at max -1. That means there is a single element. The entire space is vacant, but you cannot use this because of the simple queue logic. Right? So that is the problem of linear queue. And what is the solution? The solution comes as a circular queue. Now, again, please understand, again, it's a logical concept. Nothing actually will become suddenly in your memory, in your head, or something becomes circle. No, that's not possible. It's a concept. Everything that we are discussing, everything is ADT, and everything is a concept. Everything is a logical base. Fine. So this is the concept. You may check out this diagram, that this is your front, this is your rear. Yes, you may now circular, as it is circular queue, you may think about that it's maybe clockwise, maybe anti-clockwise, many things may be there. So if I think in this particular thing, so this is the end where, so if some new element is here, suppose you want to insert an element, say 35, so you will insert here. But if you want to delete the element, you will do it from here, right? So this way you may think that, and if you consider that this is the first position, or this is the first position, say this is first position, second position, third position, fourth position, this way, that means if you think it in this way, that means the filling out is occurring in a clockwise direction. Fine. Circular queue problem may come to you in different format. One, the simple one, that everything is going in the clockwise manner. So the moment you will insert any element, it will be incremented so and so and so, this way. Or it may comes in this way, that from the middle position, something is going on this direction, something is going on this direction. Fine. There are many formats or many things that will come, but just remember one thing. It's a circular format. Logic is, initial logic is same, that for every insertion, rear will be incremented. For every deletion, front will be incremented. Fine. Only the thing is, when rear has reached the max position, say if this is a max, but still space is available, means there is a gap with the front and rear. So that means you can use these spaces. That is the facility of circular queue. Let us go into the logics. See, for the insertion, if front is at 0 and rear is at max minus 1, or front equals to rear plus 1. Now why? See, think about this situation. Zero, max minus 1, if front here and rear here. So let us bend this one this way. Let us bend this way. Fine. Say this is 0 and this is max minus 1 position. Okay. So this way, this is the way. So if front is here and rear is here, you can see that there is no space vacant in between this front and this rear. So the queue is full. So then queue overflow is another is, that is the most interesting. You may, means you can feel that this is the condition that you maintain in the linear queue array implementation also. Then what is the specialty about this? Front equals to rear plus 1. Okay. That means that continuously the addition and deletions are going on, and at some time, say front is now here, fine, up to this level, up to max, the insertion was complete, but front is here. So again, some insertions are taking place. So now rear is here, right? So if you insert any more element, then rear will also come here. So front and rear will be pointing to the same location, and that should not be allowed. So that's why this is another overflow condition for circular queue. Okay, means when you are thinking that you are going to deal with an array with an circular queue, then these two conditions you may consider as a queue overflow condition. Otherwise, if front is -1, that means the queue is empty. Then initialize the front and rear both as the 0. If, okay, there is some query. Oh, just a minute. Yes, I'm repeating. That's why I have stopped and I'm doing the thing. And these location are 0, 1, 2, dot, dot, dot. And this location, say this is your max minus 1. Okay. What I'm trying to figure out that, say, every time initially the front and the rear is in this position, and now the rear has somehow already reached at this position, and front with some deletions has reached, say, this position, right? Now rear is pointing to the max minus 1 and front is 0, 1, 2, say 3, 4, 5. Maybe this location is 5 now. So if rear is in the max minus 1 and front is in the 5, according to the logic of the circular queue, these 0 to 4, these portions are vacant, right? These portions are vacant. So as these portions are vacant, you will get the option to use this. The circular queue will allow you to use this 0 to 4 location, means before the front. So now you insert the first element here. Okay, done. Then you get another element here, done. You take another element here, done. You take another element here, done. You are here at the 4 and front is at the 5. So now if you want to insert another element, what will happen? If you do 4 plus 1, that is rear plus 1 will be equals to front. That means what? The overflow will occur. Why overflow? Because from this 5th location till the max minus 1, already everything is full. Because of some deletions, you get some, it's like you may consider like train booking, seat train reservation, seat booking and all those things. That some agent is there who has booked 50 seats or না একটা কামরায় তো 72 টা সিট থাকে দাঁড়া 72, right? So now the passengers for whom 1 to 6, these 6 seats were booked, those are getting cancelled. So from 7th to the 72, this is already full. Obviously, these cannot be reassigned to the new passengers or waiting list passengers who can get the seat now from 1 to 6. But once 1 to 6, these seats are also full, then you cannot. And if you give some more addition or some more person, that person will মানে দুজন মিলে 7 সিটে মারপিট করবে. That's not allowed. মানে ডেটাদের আরএসি হয় না. Fine, data cannot be in half shared mode. They cannot go in RAC, not allowed. Okay. They can go into the RLWL, that is remote waiting. The moment something become vacant, they can get the confirm seat, but there is no such of RAC. Is it clear now? Yes, the we can use the space. No, not only once. We, as many time you want to use the space, you can use if the space is available. Okay, fine. So I hope I have cleared your doubts regarding the concept of circular queue. So this is the overflow condition. Then you can. Now, another interesting thing is what? If Q is empty, the front is equals to -1, then you reinitialize both as 0. But another situation that I have means from where that second overflow condition arises, that if rear has already reached the max -1, means then you need to start now from the beginning. So rear has to be reinitialized with the 0. Otherwise, you can just increment rear equals to rear plus 1 and then assign the q rear equals to the item. Yes, if the overflow condition arises, then unless until you delete the element, you cannot use the space. If deletion occurs, then the vacant space will generate, then only you can use the space. Fine. So this is how the insertion in the circular queue take place, right? Next, we'll do the deletion. So for the deletion, again, if it is in -1 front, that means that's an underflow situation. And you can just, or if it is not, then you can just print the element. If front equals to rear, just like the linear queue concept, only one element, you can print the element and reinitialize front and rear in the -1. Or that is the complicated a little bit situation, maybe when front is in the max -1. That means it's deleting the last element. Front equals to 0. If none of these situations are matching, then you can just increment front equals to front plus 1 and just complete the thing. So what you need to check, if it is -1, it is underflow. If it is equals, means single element, then reinitialize this. If it is equals to max -1, means already the end, then initialize it with the 0. And you can increment simple the front equals to front plus 1. Fine. So this way you can print the thing now. These are the few situations, not all. If some more situation is there, that these regular positions, the easy positions are not there, then you may need to think that whether these things will work properly or not. Let us check it. See, if I consider this is the situation, front and rear both are here, yes, then the -1 is correct. If front reaches the max, is anything else to do? No. So this is also correct. Is it possible that rear has crossed its location? Obviously not, because front is pointing to the last. So no such extra thing need to be done. Now, next is your displaying the content of the queue. So whenever we want to display the content of this linear queue, what we have done? Now we have displayed the content from front to the rear, irrespective of that from 0th location to the max -1 may be your array size, but you are supposed to print it from front to the rear location. Okay. But here in the circular queue, what are the situations may happen? Yes, one is okay, front to rear. When front to rear is okay, means if this is the situation, this is the starting point, say 0, this is your present front position, and this is your rear position. Then these elements, and you are printing this, that is okay. But if it happen that rear has already reached the first the max, and then again it has started with this, that means there may be sometimes when rear may be the index value of the rear may be less than the front. In that case, you need to print rear to front, this location. So think about the diagrammatic representation of the circular queue. And then if you think that how you can print, then you can go through, then you can understand that what are the different situations it may. So to deal with all those things, you may take front and rear value in two separate variables. If front position is less than rear position. So if you start from this side 0 and front is in the 5 and rear is in the 20, means in the normal, that situation. Front is less than equals to rear. Then while front less than equals to rear position, that is the same thing, the regular thing, then you can print the value. That's a easiest format or easiest representation that you can have. But other situations, come to the other situation. While front position is less than equals to max minus 1. See, this is coming as a else part of this. Front position less than equals to rear position. Its else part, that means front position is somehow is greater than the rear. But front is less than the max. When this will happen? When rear has crossed, means rear has reached this side, say around here 3 or 4 is the rear value, but front is somewhere here. So that time front may have the value index value 15 and rear is 4. So that means rear means front is greater than rear in the else part. But so from this part, as rear has again started from here and front is here, that means there are elements present here. So you may need to display front to this max position. So front to max. Okay. Now, then front position. So already it has reached to the max minus 1. Every time you are incrementing this while displaying, it has reached to this position. So initialized with 0. And then this part, when front is here and rear is here, some more elements are here. So then front to rear, all the elements. So please just make a diagram for yourself and just check whether you are able to understand all these insertion, deletion and display conditions properly or not. If you have any query, you may post here. Okay, you just check that. I'm waiting for a few minutes. Okay, so as I'm not getting any query, I'm assuming that you all have understood all these things. So next is your DQ. See, at the beginning, I had mentioned one thing that sometimes you may get, you may be asked that, do you know what is DQ? What is DQ? And people, means we got the answer in this way. The DQ is nothing but the double-ended, not the double-ended, they just is the deletion operation of Q. No. In some of the books, things are being written. Yes, that is just their convention only. But DQ is double-ended Q. Obviously, you may ask or you may think, if you have forgot the concept or if you hadn't studied the DQ earlier, that Q is always have the double end. In one side the front, in another side is the rear. Then what is the speciality of the double Q? That means is there that there are two Qs in both sides? No, it has two end, front and rear. What makes the difference? That how you can use both the end. There is a front end, there is a rear end. In general concept, we know rear is for insertion and front is for deletion. But in case of double-ended queue, yes, two end exist, but it has some restriction. It has some restriction that addition and deletion can be done from the both end. Now, if I try to do it from both end, also it may create problem. That is why we put some, first we make it unrestricted that I can insert and delete from both ends. But after that, the DQ are being go through some restriction. One is input restricted. In case of input restricted, it tells that insertion can be done only at one end, but deletion can be done from both ends. That means only one end can be considered as the rear, but both the end can be considered as the front. So for that, we may have this kind of function: insert front, insert last, delete front, delete last. So this can be front and last or left and right or one and two. This way it may be considered. So if I consider the input restricted, that means insertion can be done only at one end. Deletion can be done both end. And similarly, output restricted means deletion can be done only at one end, while insertion can be done both the end. Okay. Now, in case of input restricted, you may further think it that we are telling that insertion will take place only from one end. So you may consider it in, you may start your implementation in this way, that input will be say from the right end only and deletion will happen from the right and left both, right? So what are the things you need to look into? If you are inserting from the right end, that means every time right is a pointer, instead of rear, you may use the right and left in for the front. So if this kind of conditions are matching, you take a list and start insertion of the element from the right. Insertion for the element from the right. Fine. Input at, this is your insertion end, and output is both. So every time when you try to insert anything, so this is my left end and this is my right end. Okay. So obviously for one array, this is 0th location, this is max minus 1 location. So if these things are there, you are not supposed. And similarly, like that in the circular queue, you have maintained that front equals to rear plus 1. So every time you input an element, you need to increment, and you need to, every time you delete, you need to increment another pointer. You may consider, see, you may consider left and right as any, that's your choice. But any moment it may happen that in one side you have performed the deletion and in one side you may perform the addition, and at some time there is a chance that it may overcome or it's already filled up or that kind of thing. So that means there will be one overlapping situation. So if this kind of things happen, you may consider that is overflow condition. Yes, writing program means when you are writing the program of a DQ, it will be either input restricted or output restricted. That's up to you, or that's up to your problem definition requirement. So for insertion, what we need to do, first I need to check the overflow condition. Then say you, if you take this as a your pointer, you may take left as -1, then assign like front equals to -1, you may take left as -1, then assign left equals to right equals to 0. If right is max -1, then assign right equals to 0. If those things are not satisfying, then right equals to right plus 1. If you think properly, DQ, almost all the operations are very similar to the operations of your circular queue. Almost the concepts are same. So every time you think about all this queue implementation, draw the thing and do accordingly. Unless until you do this, whatever you want to say, it may not, whatever, if you go it randomly, things will go wrong. So these are the possible conditions that you need to check. Every time during insertion, just need to remember either overflow, or if there is a, or it's a initial point, or it's a right has raised the max -1. So right here may be considered as similar to the rear, then it's initialized with 0, or it will be incremented. And after that, you will assign the value. Similarly, output restricted, you may consider input at one end, say right, input at another end at left, and you say that you may consider output restricted means deletion supposed to be restricted, and you may consider that deletion will be restricted at the left end only. So almost same things to be checked. Overflow condition remains same as it is. For the insertion also, you may do it with the left pointer, and as you are using the left pointer for insertion, you may implement it as left equals to left -1 for each of the increment, and then you can assign the value. Now, if you want to delete from the right, then these may be the conditions. If right equals to -1, overflow. If left equals to right, like the front equals to rear, if both are same, that means the single element, then reinitialized everything to the -1. Otherwise, if right 0, then you make the right to the max -1, or right equals to right minus 1. So if you are deleting from the right, that means if your Q is like this is your right side. So whenever you are deleting, if right is -1, underflow. Otherwise, print the rightmost element. If left and right both are in the, because if your deletion or insertion for anything, if both are pointing to the same location, say this, then that is the last element, again reinitialized. If right is 0, then you may assign right equals to max -1, or you just need to decrement the right equals to right -1. Okay. So similarly, if you want to do it from left, you need to do the things just the same way, but think that everything is going from the left side. So for this, left will be incremented, because when you are deleting from the left, things will go from this side to this side. So you can perform the increment. When something is coming from that side, we are supposed to do the decrement. Okay, so from which side you are operating at which time, based on that, your logic should be written. Otherwise, what will happen? Everything will be jumbled up. You may lose the track. Lose the track means lose the elements at any way. And displaying is almost same as the circular queue. This is another very important, that is the DQ is another very important category of the queue. You may get just verbal question and as well as the programming type of question based on the concept of DQ, based on the concepts of circular queue, and the numerical type of problem solving, that this is a queue operating in this direction and these elements are being inserted, these elements are being deleted, then what will be the final position of front and rear, and what will be the content in between front and rear. So this kind of thing will be there. So for that you should have the knowledge about this queue. Otherwise you cannot implement it. You cannot solve that kind of problem. Okay. In the last class, I have discussed about the multiple stack. That is, in a single array, more than one stack can be implemented. Similarly, in case of multiple queue, in one large array, more than one queue can be implemented. But although everything is logically, direction, obviously already insertion deletion is means for a queue that is in the both end. So for multiple queue also can occur in two different way. Maybe for both the queues, the insertion may take at the left end, or for one queue it is coming from the left end. For another queue, it may be coming from the right end. That's up to you. Means how you can implement those, how you will write the logic for insertion and deletion. That is completely your choice. You may go through in this way, that you are taking for Q1 -1 as a rare one, for Q2 as a max. Similarly, for front, you may take these values. And every time you insert for both the Q, rare 1 and rare 2 is, rare 1 is, if it is rare 1 is going in the direction of left to right, so rare 1 will be incremented, and rare 2, if it is means Q2 is working in the right to left, then rare 2 will be decremented. So it may happen that at some moment of time, rare 1 and rare 2 almost in the adjacent positions of each other. So It may go to the overflow situation. If this kind of situation do not occurs, then you can increment the rear and you can assign the value. Similarly, for underflow, same kind of thing, front equals to -1. Or now, for the deletion, so for insertion in the Q1, you may check it in this. But for deletion, you just check if front equals to -1, that is the underflow. Otherwise, just delete the element and increment the front. Similarly, for insertion of the Q2, you need to check the other thing. Rear 2 is coming from right to left. So I'm coming from 10th location. So 10, 9, 5, 10, 9, 8, 7. I'm in the 7th location. And rear 1, say in the 6th. So 6 plus 1, that will become 7. So if I want to insert more element, that will overlap in the area of the Q2. So this is can be considered as the overflow condition of the Q2. If this kind of things are not happening, then decrement the rear because it's coming from the right side. So decrement the rear and you can assign the value. Deletion of the Q1. Sorry, this will be deletion of the Q2 because I have already, yes. Deletion, this will be just a type of error. This will be Q2. So in case of underflow condition, if front 2 is into the max. Otherwise, you just delete and decrement the front, increment front. And another type of queue, which is called as a priority queue, you will get the application of priority queue in the area of heap shot and that kind of thing. What happens in the priority queue, that elements are inserted, deletions, everything is being done with their priority. All the elements are being associated with some priority value. So in the normal queue, where the normal data are being inserted, we deal with the fact that the element which is inserted first will be deleted first. But in case of priority queue, the things are not exactly same. The higher priority element can be deleted before the low priority element. If more than one element are having same priority, then only we will apply the FIFO rule. Otherwise, in case of priority queue, all the operations are being done with or as per their priority basis. Okay. It can be implemented using array and linked list. Anyway, I will discuss these priority queue and it's everything because it's a long thing. Is not possible to discuss today. So we'll discuss the priority queue and some interesting problem of maybe stack and queue. We'll discuss in some other day. Okay. So thank you. I can stop now. If you have any query, you may put forward. Otherwise, go and have your lunch. If you have any query, you may put or you may leave now. Okay, thank you. Okay, so I'm ending this meeting. You may walk out now.